Hello and welcome to another Python Game Making for Beginners tutorial. In this video, we're going to cover the final topic before we get into actually making our first graphical video games by using the Python module Python Arcade. So this video is going to focus on OOP, or Object-Oriented Programming. So a basic grasp of OOP is going to be necessary in order to really understand what we're going to be doing with Python Arcade. So before you get into this video, you should have a pretty basic grounding in Python, as we're going to be getting into some intermediate territory. So you should know how to define variables, you should know basic syntax, you should also have a pretty good familiarity with how to define, call, and use functions, as we're going to be using a little bit of that. We're basically going to be combining everything that we've done so far into this new topic of object-oriented programming. So before we get started, be sure to go ahead and hit the like button, subscribe if you haven't already, hit the notification bell so you never miss one of my new videos, and let's get ready to dive into object-oriented programming. So the first necessary step to using object-oriented programming is to understand what classes and objects are. Thankfully, we've already been using classes and objects all along if you've been following along with this series. But we've been calling them by slightly different names. So you might remember me talking a lot about basic data types, such as integer, float, strings, and booleans. And I'll actually show you a really quick function that you can use real quick. I've got my idle environment open. There's actually a function, a built-in function called type. If you use the type function and call as an argument pretty much anything you want, like I'll just put in a number, the number 3, then it will tell you what type it is. That is of type class int, or integer. If I do type and then put something in quotation marks, then it will give me type class string. So notice that every time I do that, before it gives me the data type, it says class. That's because that string, integer, float, boolean, these are actually classes in Python. I like to refer to them as data types earlier on because that's a little bit more descriptive of what they actually are. But now we're going to get under the hood and actually learn what a class is and how it can define our own classes. So something else that we can do is we can store these different classes in a variable. So if I do name equals quotation Adam, oops, there we go. So now whenever I call the variable name, then it calls the name Adam, or the string Adam. And I can also use typing on that. Let's type in my name variable, and of course that is of type class string. So every time I store something in a variable, I am creating an instance of that class, or sometimes it's called an object of that class. I can do the same thing with numbers. If I do age equals 40, now if I do type age, that is of type class int, or integer. So now I'm going to show you how you can create your own classes if you need something that can't be described by any of the built-in basic classes or data types in Python. So I find that the easiest way to really understand what classes are and what they do and how to create them is to create an analog of a real-world object. So we are going to create a class called car, and all it's going to do is to describe the very, very basic things that make up a car, something that we, deal with in our day-to-day lives. So the way to create a class is by using the keyword class and then the name of the class. So class names follow pretty much the same naming rules that we use for variables, but by convention they start with a capital letter. They don't have to, but that's expected. Oops. So we're going to create a class called car. After that, you can optionally have parentheses. I don't believe they are 100% necessary, but that's a good habit to get into. Kind of like when you define a function, but in functions, the parentheses are necessary, even if they're empty. So again, for a class, I don't believe you need them, but we're going to put them there anyway. All right, and then it's going to expect a body where we're going to describe the car, and for now, we're just going to pass that. And that's all it takes. That's all it takes to create an empty class. So now we have a class called car, but there's nothing really in it. We can't really do anything with it. I can assign it to a variable or instantiate it, create an instance by doing my car equals car. And we can do that. So now if I call the car variable, or I'm sorry, my car, then it tells me that it is main.carObject at, and then a big weird string of letters. So this string of letters is the memory location where car is being stored, because when we instantiate it, we load it into a memory location so we can do things with it. We can also delete it from memory. I'll show you how to do that in just a moment. So at the very beginning, we have double underscore main double underscore. So whenever you have something that is has double underscores before and after it, we call those dunders for short in Python. And that is basically a magic variable or a magic function. And by a magic variable, that just means something that just exists. Python creates that for us. We don't really have to worry about it. And this is just telling us what script this is in. This is in our main script file. Later on, we're going to deal with using multiple script files in one program, and this just tells you which one that class is located and where it's defined, in case we need to go and fix anything with it, change things, add things, whatever. All right, so if I go to delete my car, then it will, oops, not define, delete del my car, that will remove it from memory. So now if I try to call it, it doesn't exist. I've got to load in a new one. There we go. And now it's back, but in a different memory location, which is okay. It just pretty much sticks that in a random spot in memory. All right, so now I'm going to show you how to add attributes for it, things that actually describe what a car is. So think about some things that might be important to a car, such as model, make, and color, for instance. So if we wanted to tell it what make and model that car is, then we would do the name of the variable, my car, and then dot, and then whatever attribute you want to assign to it. So we could do my car dot make equals Ford. My car dot model equals Explorer. This is going to describe an old car that I used to have. And then my car dot color equals, mine was gold, so we'll say gold. And then I can call any of those different variables or attributes by just typing in mycar.make, and it will tell me what it is. mycar.model, mycar.color. So I can also create another object of that same class. I can create a different instance. It's going to be the same type, but it can have different variables. It's going to have a different spot in memory. It's basically going to be its own thing. So let's create a variable called otherCar equals car. And then I can say otherCar dot make equals Nissan. Oops. There we go. Put in my variable name wrong. OtherCar dot make equals Nissan. OtherCar dot model equals Murano. OtherCar dot color equals black. Oops. Oh, my microphone stand's getting in my way. I can't see what I'm typing. There we go. And then just like I did before, I can call any of those variables, otherCar.color, myCar.color. Handles it pretty much just like any variable we normally use. And then if I call myCar, then of course it will show me that location in memory. And then otherCar, it will give me a different memory location. So I can even give these the exact same attributes. So for otherCar, I could make it a, Ford Explorer that is gold. And even though they'll be identical at that point, they're still going to point to two different memory locations. They're still two separate objects. That is the most important thing to understand, is that we're basically, again, creating like a copy of this class. Every time we create a copy of it, it points to a different object entirely. All right, and once we have all of those attributes in place, we can change them if we want to. Like, let's say that we wanted our Murano to be red. OtherCar.color equals red, and that will change that. There we go, changes it to red. And then of course we can delete those from memory. Delete my car, delete other car, and now they no longer exist. If I try to call them, nothing comes up. All right, I'm going to go ahead and clear this out real quick. All right, now I'm going to show you how to create a class with the attributes already there. So I'm going to create another class, car. So we're going to do class car. And now we're going to create a function inside. So you may remember before we worked a little bit with a specific type of function called a method. And a method is just a function that acts on a particular class. I'll go ahead and give you a quick refresher on that really quick. For instance, if I create a name variable, so that equal to Adam, and then let's say we wanted to print that name but all in uppercase, we could use the .upper method. So we would do name dot upper and then our empty parentheses. There we go, and then it converts it all to uppercase. Of course, it does that in place, so if I type that again, it doesn't actually change it because strings are immutable. If I want to change that, I've got to reset the variable, reassign the variable. But again, that upper class, or the upper method, only works on something that is a string class. So if I do age equals 40, and then if I try to do age.upper, I get this. I get an error. Attribute error. Int object has no attribute upper. So before I was calling those variable attributes, and attribute is basically anything that you put, pretty much anything you put in a class, whether it is whether it's a variable or a method, any number of different things. All right, let's clear that out one more time. Okay, so now we're going to create our full car class. So let's say class car. And so here we're going to create a method, a special method called an initializer. And I mentioned a moment ago magic methods or magic variables. So we are actually going to use a magic method now called init, which stands for initialize. And every time we instantiate or create an instance of this car class, it's automatically going to run this initializer function, which we're just going to make it give attributes, all of our attributes that we want. So our arguments inside this function are going to be any attributes that we want the car to have. Like, let's go with the ones that we used before. So we're going to do make, model, and color. And every single function or method inside of a class also requires another argument called self, and it has to be the first one. So before you have anything else, you have to have self. So before, we created two instances of the same class. The reason that you need the self is because that's referring to that specific instance or that specific object of that class. And then we also have to do the same thing down here after we put our colon. So this works just like a function, but now we're going to set all of our variables. And before I did, when I created the mycar, I did mycar.color, mycar.make, mycar.model in order to set all of these different attributes. So we're going to do the same thing here, but we're going to use the self variable. So again, self refers to that specific instance of that class. So we're going to say self.make equals make. And we're going to do this for each one of those attributes. Self.model equals model, and then self.color equals color. And that's all we're going to do for right now. So now whenever I create an instance of that class, so we'll say my car equals car, and then I'm going to start my parentheses, and you see it automatically tells us what we need. The self is gone because my car, the variable name, that is self. Again, it's just referring to that specific instance. But when we create this, we have to give it a make, a model, and a color. So we're going to say Ford Explorer. Oops. There we go. Gold. And so now if I call mycar.model, mycar.make, mycar.color, then it'll pull each of those up for us and let us know what they are. I can create another one. Other car equals car. And Nissan Murano black. There we go. There we go, and everything works just like it did before, but now we just create all of those different attributes automatically whenever we create the class. And then we can also change them just like we did before. MyCard.color equals black. MyCard.color is now black. All right, let's go ahead and clear this out one more time, start over again. And we're going to do a couple of more things before we finish this one up. Let's say that we wanted to have default attributes, or we want to be able to tell the user what specific type of attributes or what type of classes or data types we're expecting for each one of these different attributes or parameters. So let's go back to our class car, and we're going to create our initializer. Self make model color. There we go. And this time, let's say that we want to tell them that it has to be a specific type of a specific data type. So we'll say make, and then we'll put a colon str for string, model, same thing, str for string, color, str for string, and let's add one more. Let's add year. Just to have something different, and that's going to be looking for an integer. And then we finish this the same way that we did before. Self.make equals make, self.model equals model, self.color, equals color, and then self.year equals year. So now when I try to create a class out of that or create an object, my car equals car, now it tells us specifically what type of data that it's expecting. It's expecting a string, 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 and then an int. So Ford Explorer Gold 2001. There we go. So it's worth noting that you can put a different data type. So if it looks for an integer, you can put a string there and it will not break the program. This is just to let anybody else know if they're using this, or to remind yourself if you're using this later, what type of thing you should put in there. And you should follow those conventions that you put. Otherwise, it could cause your code to behave in strange ways, but it will not break the program. It won't give you an error if you try to put in something different. So if I do mycar.year, and put that in as a string, it will let me do that. But again, you shouldn't do that. All right, now let's try this. Let's do class car. Just going to redefine that. And this time, we're going to give it default attributes. So we can say make equals Ford, model equals Explorer, color equals gold. Oops. And let's try that one more time. There we go. So I put all of my attributes there like I did before. Self.make equals make, self.model equals model, and so on. So now when I create that class, or when I create an object, my car equals car. So now it lets me know what the defaults are. I accidentally put in gold instead of gold, but I think we get the picture. So now if I don't put in any attributes, and I accidentally put year in and it doesn't belong there. That's why that messed up. Let me fix that one. Let me fix that real quick. There we go. So now if I don't put in anything, it will automatically use each of these default attributes. So now if I I don't have to put anything in, and if I just do self.make, mycar.make, there we go, then it will give me Ford back. All right, and we will do something else with this real quick. So we can also have optional attributes. So let's create another class, car. All right, so if you use a combination of required attributes and optional attributes, the required attributes must come first. So on this one, let's say that we are not going to give it a make or model. So let's do make, model, and then for color, we're going to give it a default, and we'll say color equals gold. There we go. We'll finish this one out the same way as we did before. So now when I call that one, let's do my car equals car. And so now it lets me know that my make and model are required because they don't have a default. And then color is going to be an optional attribute. If I don't put that in, it will automatically assume gold. So let's do Ford Explorer, and that's all. So now it automatically assumes that that color is gold. So even though I didn't put in there, if I do mycar.color, then it will tell me it's gold. And of course, I can change that just like I did before. Or actually, let's do this. Let's delete my car. Now let's do my car equals car Ford Explorer. And then we'll put in a different color, black. There we go. So we can put that in if we want to, or if we don't put anything in, then it will assume the color because we added a default color there. All right. That will about bring us to the end of this video. I'm going to go ahead and do one more video on this to cover methods as well as inheritance, which are both going to be very important to our future game making videos. But for now, if you want some extra practice with this, and you should get some extra practice with this, try doing basically what I did. Just try creating an empty class and adding attributes to it, changing the attributes. Try creating a class with the attributes using the initializer method like we did up here. And just try creating a description of a real world object or thing or animal. Create a class called dog and then populate it with the attributes that a dog would have, like, you know, weight, length, color, you know, things like that. And we'll talk about some other things we can do with that later. But before you go, don't forget to hit the like button, subscribe if you haven't already, hit the notification bell so you never miss one of my new videos. And with that, we will see you in the next one. Thanks for watching. Goodbye.